Okay. All right. So let's talk about what's going to be on your test on Monday. So vocab-wise, obviously you're going to need to know all the formulas, right? General exponential growth and decay, compound interest, continuous compound interest, and half-life. Okay. You're also going to need to know all the different values of n for your compound interest formula, right? Like what's the value of n when interest is compounded annually, semi-annually, monthly, daily, all that stuff, right? So all the formulas and all the values for n for your compound interest formula, right? And you're gonna see one problem each for the formulas, right? Like you'll have one problem for general population growth or decay. You'll have one problem for interest and one problem for half-life. Okay. Now each of those problems will have multiple parts, so be aware of that. Okay. Let's start with this problem here. Okay. So I had to come up with something last minute, so I just used Whoville as an example. Whoville has a population of 500 people, which has been increasing by 2.3% every year. If this trend continues, what will the population be in 10 years? Okay. So remember, so this is a population growth or decay question. So we're going to be using the general population growth or decay formula. A equals P times 1 plus or minus R to the T. Okay. Which of those four variables are we looking for? Out of those four variables, which one are we looking for? Which one are we trying to find the value? A. Okay. So that's what we want to know. Let's try to see if we can find all the other ones. What's my value for P in this problem? 500. 500, right? That's your initial amount. It's your starting amount. So P is 500. What's my R?
0.03.
Good. Yeah. So remember, when you write your rate, when you write the value for R, it should be in decimal form. So here it's in percent form. So I'm going to convert that to a decimal. 0.023. And what's the value for T? 10. Yeah, 10 years. All right. So question is, if this trend continues, what trend? What's the trend? It's growing, right? So what part of the formula here are we using? Are we using 1 plus R or are we using 1 minus R? 1 plus R. All right. So let's put in those values. So 500 times 1 plus 0.023 to the 10th. Okay. And let's simplify that. 500 times 1.023 to the 10th. Okay. Now, on the test, it'll tell you what decimal places to round to. So you don't have to worry about that. But just know in general, we're talking about people. So what should we round to? Whole number. Okay. So let's put this in our calculator. 500 times 1.023 exponent 10. Put that in. I get 627.6. So that's going to round us up. 628 people. Okay, simple as that. Identify your variables, identify which formula you're using, substitute, evaluate. Okay. All right, any questions on that? Don't forget to make sure you know the difference between 1 plus R and 1 minus R and which one to use for which situation. Okay. Let's move on to the next one. I put $1,000 into an account that gains 7% interest. How much will be in the account in 5 years if interest is compounded monthly or continuously? So that's two different parts. So we're going to be using the formula 2 different times. Okay. Do I know what A is? Do I know what A is? Oh, by the way, actually, before I do that, let me actually write the formula. This is compound interest. A equals P times 1 plus R over N to the NT. Okay. Do I know what A is?
Yeah.
No, that's what I'm looking for, right? I want to know how much is in the account after that time has passed. Okay. What's my value for P in this problem? 1,000. Right? So P is 1,000. What's my value for R? 0.07. Good. What's my value for T? 5. Good. Now, let's figure out the other part. Because remember, there are two parts, right? One where interest is compounded monthly, one where interest is compounded continuously, okay? If my interest is compounded monthly, what's my value for N? 12, good. 12 months in a year. What about continuously? What about continuously? Not quite. What's the value? What's the value for N when interest is compounded continuously? So, well, hold on. See that? Say it again. Okay, yeah, that's right. There is no N. So what do we have to do? What do we have to do if interest is compounded continuously? Use the other formula. Remember, there are two formulas. One of them is specifically for when interest is compounded continuously. So there's no N for continuously. We have to use the continuously compounded interest formula. A equals P times E to the RT. Now, E is involved, but E is not the value of N. Okay, so because there is no value N. All right, so let's start with part A. We got everything we need. We'll start with part A. A equals 1,000 times 1 plus 0.07 divided by 12. And then my exponent is 12 times 5. Okay. Let's see. What's 0.07 divided by 12? All right. So that's a repeating decimal. So sometimes if you can't simplify this, just try to do it one step at a time. Okay. Because it's not going to be like the Math Excel where I'm asking you to write the formula first before you actually solve it. Okay. So just evaluate this. So I'm going to figure out what this fraction is. I'm going to add 1 to it. Then following order of operations, now I'm going to raise it to this decimal, which 12 times 5 is 60. Okay. So raise that to the 60th power. And then I'm going to take that number and multiply it by 1,000. All right. Now keep in mind, this is money. So what decimal places do we round to? How many decimal places do we round to? 2. All right. So that's $1,417. And I get 0.625. So that's going to round up. 63 cents. Okay. For part B, again, this is where we use the other formula, the PERT formula. Okay. So A equals 1,000 times E, and then my exponent is 0.07 times 5. That I will simplify. 0.07 times 5 is 0.35. Okay. So I'm going to put in my calculator 1,000. Remember, E is second ln, and then I just put my exponent, 0.35. And again, this is money, so we round to 2 decimal places. So my decimal is 0.067, so that's going to round up. All right. So $1,419.07. There you go. There you have it. Okay. So make sure you're paying attention to how many times interest is compounded. Because if it's compounded continuously, that's a whole different formula. Okay, it's a whole different formula. All right. Any questions? Okay, let's move on to the last one. You guys all drink soda, right? Caffeine has an average half-life of 5 hours. If you consume 40 milligrams of caffeine, how much of it will be left in your system after 7 hours or 1 day? So again, same logic, right? We have 2 parts. We got to work the formula twice, okay? So remember, half-life formula is A equals P times 1/2 or 0.5, whichever you prefer. 1/2, and my exponent is T over H, where T is the amount of time that passes and H is the half-life of the substance. Okay. So let's identify what our variables are first. What's my P? What's my starting amount? What's my value for P in this problem? 40. Okay. What's my value for T? What's my value for T? Well, actually, let's break that apart, because remember that's two parts, right? Part A, what's my value for T? 7. What about B? What's my value for T in part B? Good. Why? Exactly. So the problem is, so the half-life is in terms of hours. So you want the value of time that passes to be the same unit of measurement. So if my half-life is in hours, then the amount of time that passes should also be in hours. And how many hours there are in a day? There's 24. All right. So T is 24 for that problem. What's the half-life? What's my value for H? What's my value for H in this problem? 5. Because that's the half-life of caffeine. Okay. So let's start with part A, right? So A equals 40 times, and I'm going to use the decimal form since that's easier to put on my calculator. 0.5, and my exponent is 7 over 5. Now, if you want to calculate 7 over 5, you can. That's totally up to you. That's 1.4. So let's do that. 40 times 0.5, my exponent is 1.4. And the reason that I'm doing this is because if it's a terminating decimal, if it's a nice looking decimal like 1.4, that's easier to put in your calculator than trying to put a fraction calculator. But I will warn you, if you put your exponent, if your fraction is an exponent, make sure you put that in parentheses so that your calculator will calculate the fraction first and then apply it to the problem. Okay. So 40 times 0.5, exponent 1.4. And we're going to round this to about 1 decimal place. So I got 15.15, so that's going to round up. So 15.2 milligrams. Okay. For part B, you're going to apply the same formula, except this time the value of T is 24. So 24 divided by 5 is 4.8. So A equals 40 times 0.5, and my exponent is 4.8. So I'm going to apply the same formula, just change the exponent. We're going to round that to 1 decimal place. So that's 1.4 milligrams. So if you think about it, if there's 40 milligrams of caffeine in a soda and you drink the soda, it'll take a whole 24 hours for it to be whittled down, that caffeine to be whittled down to 1.4 milligrams.